Professor Magedanz, and also Dr. Corici. So let me introduce them. Both speakers are globally recognized pioneers in applied research of programmable networks and software-based networking and the development of mobile core networks software toolkits, such as an Open EPC and Open 5G core, which are used by industry and academia to build customized open technology testbeds to prototype innovative mobile applications for different vertical domains. So last speaker will make a presentation about get 6G-ready design aspect for emerging 6G organic core networks. Let's welcome the last speakers.
Okay, ladies and gentlemen, my name is Thomas Magedanz, and I have the honor to give you a short presentation about our 6G-ready activities, and I do this together with my dear colleague, Dr. Marius Corici. So the title of this presentation is called Get 6G-ready, Design Aspects for Emerging 6G Core Networks. So what we plan to do is on the agenda slide. And here I just want to give you a rough overview what we are doing in our business unit, and then address a little bit what are currently the technology drivers for the new 6G technologies from our perspective. And then we want to drill down into our core competency, which is the design and development of new innovative core network software toolkits. Last but not least, we of course want to tell you a little bit about our roadmap, because 6G is just in the beginning. And so we will illustrate to you how this evolution is envisaged, and a summary and outlook will pave the way to a question and answer session if possible. So some people may know us, some people may not know us. So we are quite active in the past 30 years in what we call research and prototyping of new emerging telecommunication standards. And as the world turns into a software-based networking environment, we are doing this since the early beginning. And of course, people knowing us know that we are in Champions League in this regard. So we are working with prestigious tier 1 network operators, research organizations, and vendors all around the world. We have two pillars of our activities. One is that we run our own testbed infrastructure and open technology infrastructure, vendor independent, based particularly on our toolkits. And secondly, we enable our partners and customers to build up their own testbed infrastructures based on their own toolkits in combination with our toolkits. We call this testbed to go. Next slide, Marius, please. So this slide you will now see is just illustrating a coincidence of our toolkits in the past, where we have been active in 3G, 4G, 5G, and obviously now we are also moving into the 6G space. And the bottom side is illustrating the playgrounds or test beds which we have built around these technologies. So we will concentrate on the Open 5G core network evolution in this context here. So what are the technology drivers for 6G? And honestly, there are two different views on this, and as you can move to the next slide. And before I come to this, I just want to address that obviously we talk about 5G evolution on the one hand, and the building of a new technology, which is these days called 6G. So from a research perspective, we have two research markets which are currently out there, which have to be addressed. And we particularly envisage that the 6G research market is now establishing in parallel to the 5G evolution market, and at some point in time will take over. And this is probably in reality happening in the next 3 to 4 years. But now a lot of research programs are out there in order to develop basic fundamental concepts for the new technology. Next slide. So what we can witness when we look at the technology impacts, and you can go even to the next slide. So we will skip some of the slides, which you can download later on. So you see there are multi-impacts on the evolution of 5G, leading it towards 6G. And we particularly follow the idea that 6G will stem from a 5G evolution. And currently we see a lot of innovation happening in what is called campus networks, and particularly, and I think you have to go back one more, Marius. So what we see in the term of evolution is that we have campus networks driving this. We have currently Open RAN and the disaggregation of the RAN functionalities and core network functionalities, as well as this is called RAN core integration. We have a lot of discussions about digital sovereignty and component-based infrastructure building, where we need trust and security in order to identify the different components coming from different vendors. We also see, and I think this is most important, a new radio interface coming up, and this is the 6G terahertz communications, which enables also new ways for sensing and localization of devices and users, and of course also new interactivity patterns with the network platform. So next slide, Marius. So in principle, what is currently happening is that when we look at the classic triangle, which we all know from 5G, that in the 6G context, we will see much more combinations of the previous identified extended multimedia broadband capabilities, ultra reliability, low latency, and massive machine type communications corners of this triangle, where we see particularly many specific combinations of those in the reality for fulfilling specific use cases. We don't have the time to go into detail here, but the 6G infrastructure has to support a high variety of these very different use cases in a very flexible way, and obviously also in a dynamic way in the future. Next slide, Marius. Another dimension here, and what I not mentioned on the first slide where we listed the impacting technology, is that in addition to terahertz communication, which is a very local communication, short-range communication, and the traditional 5G communication, which of course also has to be supported, we also have satellite communications and non-terrestrial network communications to be integrated. And this leads also to what we call different types of mobility and coverage area variations. So this means you see here on this slide that 4G networks had a very specific scope for when they have been set up. We see now, particularly with 5G and the discussion of campus networks, that we also see temporary networks and smaller networks in addition to the national networks. And then with 6G, we see that we also have moving networks, temporary mobile environments for many different short to national coverage areas. So next hand slide, Marius. So last but not least, in order to address all these different impacts, we particularly in our research focus on these illustrated directions here. On the one hand, the interesting RAN core integration, which is starting these days with the global discussions about Open RAN. And in this regard, this will, in a full-fledged way, go into 6G. We talk about organic core networks, and Marius will elaborate on this much more, in the sense that we can integrate dynamically new access networks and backhaul networks, and in this regard have very different breathing network environments to cope with specific coverage offers and service support activities. Data will play an important aspect here or role here, because we think about zero-touch networks and artificially driven environments which are adapting to specific user needs, but also sustainability goals in terms of energy savings. And on the right-hand side, you see also the notion of scheduled networks, where we particularly, based on learnings, can set up specific network connectivities at specific places where it is supposed to be needed in a future time frame. Reliability and security are very important aspects, because we have learned from the 6G journey that networks have to provide a high reliability in order to support the different use cases. And security obviously stems from the fact that we have various components coming in the future from various suppliers, and of course also interworking of different network types, being it access core and backhaul and so on. So I move on to Marius, and you can take this next slide then, Marius, in order to go on.
Yes. So following these technology drivers, there are specific design aspects that relate directly to a next generation core network and how this would be integrated ultimately into this core network design and architecture. There are specific trends into the 6G network that will significantly impact the 6G core network architecture. As mentioned by Thomas a little bit earlier, the convergence of the RAN functionality, the localization of core network functionality within the edge, as well as the relationship with the infrastructure, especially in the terms of security, reliability, and performance, will greatly impact the deployments which are localized. Furthermore, as we have more and more dependencies between the edges and the central entities in terms of delay, reliability, and network capacity, there is a strong need to integrate the transport networks as well as to support the dynamic migration of functionality between the edge and the central elements. And of course, with the advent of the machine learning, we are talking about highly dynamic, data-oriented system customizations like scheduling instead of only having protocol optimizations. What is also new with 6G is mostly related to the deployments. In 5G, we had static networks with micro operator networks, with dedicated slices, with smaller non-public type of networks deployed within the environment, overlapping with each other and providing connectivity for the devices. In 6G, we have a new type of networks which morph based on the active subscribers and based on the service requirements. Different pieces of the network can migrate to new infrastructures. Load can be split between the local and the central infrastructure, and why not, functionality can be merged together and create new sorts of functionality that is needed at different edges or at different central entities. Of course, the new core network will have to support terahertz communication. Terahertz is using currently unused spectrum, very high frequencies, and with this there is a hope to provide very low delay transmissions and very, very high capacity. Nonetheless, terahertz communication is based on beam steering, and a massive MIMO is needed in order to maintain the connectivity to the devices. Also, terahertz comes with a reduced coverage, so it needs a sort of very fast handover support. And it is meant only for very low speeds because the beamforming would take too long actually to be able to be executed at high speeds. And also the coverage would not permit for such things. Now, signal can be lost very fast. We need a new mechanism for break before make in the handovers within the core network. For example, to use a carrier aggregation where the most of the signaling will go over the under 6 gigahertz communication, and only the extra data or the big bulk of data will go through terahertz. So there is a need at this moment, first of all, to understand the user profile, to understand the speed, the location, the state of the communication, if such terahertz communication would be needed and in which quantity, and so on. So the core network has to encompass at the end all of these features within the functionality itself. And these are actually additions to what we have today into the 5G networks to be considered. Now, the 5G core network architecture was based on network functions. Each of the different functionality was placed into one of these network functions. Each of the network functions can be at the same time implemented as a microservice. And these microservices were connected in a service-based architecture using HTTP2, a support communication protocol, which is highly flexible into the selection of the next network function, permitting a very good scalability at the network function level. Now, Before going forward, we should go into a very short understanding what is a network function. So a network function is a very basic element of the network, which has a very well-defined input and output, a transfer function, which transforms the input into the output, and the subscriber state, which influences the transfer function, how to change the input into the output. These are the four elements that define a network function. Now, to be able to make the network functions interoperate, the input and output interfaces, as well as most of the time, the transfer function are standardized by 3GPP. Now, this model was very good for components, physical components that were connected with cables. However, it has several limitations when we discuss about software networks, meaning three. One is the isolation of the state. Each of the network function has its own state. So whenever a procedure is executed and we need to announce the multiple network functions about the change of the state of the user equipment, this has to be done explicitly by exchanging messages between the network functions. And most of the messages exchanged into the core network procedure is only for synchronization of the states with minimal impact on the transfer function. Second is that the state and the transfer functions are bound together. So no matter if this would be externalized to another component, still together are seen as part of a single network function. This makes the procedures of migrating subscribers and handing them over to other network functions rather complicated. Third, and probably the most important, is that when the input interfaces are fully standardized, it is very hard to introduce new functionality and new services, unless it uses only what it was already standardized as input interfaces. Otherwise, it needs to actually go into standardizing the next function, which may have to standardize the next one, and we have a cascading effect of standardization for every new service that's added to the network. Now, these elements can be rather well mitigated when going towards a more software-oriented architecture, breaking this type of a cell boundary for each of the network functions. What we need to do for the 6G core network is, first of all, to support all the core network functionality as it is now: access control, connectivity management, mobility management, and so on. But also to support this type of new features like infrastructure-free implementation, to be able to migrate, organic growth, to be able to adapt to the different subscribers' requirements, to simplify the addition of new functionality, and to reduce the complexity of the network, and at the same time to maintain very fast scaling and high parallelization capacity. Of course, we need also to look at the network management to be able to have a continuous integration and a continuous deployment, and to simplify the network management system, which became more and more complicated with the complexification of the core network. A key aspect for the new design of the core network is the functional split. How to split the functionality between edge nodes, central nodes, and other remote nodes where the infrastructure can handle such functionality. This is one of the aspects, how to integrate with the access, but also we have the aspect of security, to secure the connectivity between the different entities within the system, as well as to assure that the communication will be handled correctly across the transport networks, be it satellite networks, terrestrial networks, other wireless networks, and so on. So core network cannot be seen as sort of independent and autonomous entity. The core network has to be seen in integration with the infrastructure, with the transport, as well as with the security between the different nodes within the network. Additionally, we have to maintain still the end-to-end perspective, where we have user end systems that will evolve in the 6G forward. We will have more capacity on the devices. We will have more variation on the use cases, as well as by the adoption of the machine learning as a key way to have insight on the way that the system behaves for network management purposes, and the integration with the applications that may come from different industries with different purposes and with different goals. This being said, I will hand over back to Thomas for the roadmap of our 6G activities.
Okay, thanks, Marius. And I think we will go much faster through the last slides. So the next one. So you know that we have what we call our dirty hands of hacking. We are building toolkits which people can use to build up their research infrastructures. And basically, we have a roadmap for this evolution of the 5G core infrastructure. And one stamp we put on top of this infrastructure is Open RAN ready. So this is the evolution of 5G by incorporating Open RAN disaggregation principles in the near future. And we have a large project which will cover these kinds of developments. And then we are engaged in three more projects. One is a Fraunhofer project, 6G Sentinel, which particularly is addressing from a Fraunhofer perspective the evolution towards 6G, where we will evolve our open 5G core towards 6G readiness by including Terahertz communications and non-terrestrial network infrastructures and adopting some of the principles which Marius just has explained. Last but not least, we are also majorly participating in the new German 6G hubs infrastructures projects, and here we are going for the development of an organic 6G core. This basically means we are developing from scratch a new kind of dynamic core infrastructure toolkit, which is really adopting the main new principles and starting to develop from scratch in order to have really a clean slate approach for the new generation of networking. I don't go into the details of any of those projects because we are otherwise taking too much time here. So you can see on this slide that this is a staged approach. So this means that our customers and partners, which are currently using the Open 5G core, are basically being able to benefit from this evolution if they are interested. And you see the corresponding infrastructure projects and facilitating projects listed here below. So I think, Marius, there might be a last slide. You can skip these slides. So the key message of this presentation is we have a long tradition in building up reasonable software and test beds all around the world. And we are going to extend our expertise and toolkits in the next years with the already secured projects. We are happy to work with new partners and new customers in the future. And we hope that this video is attracting your interest, and we hope to get in touch with you in the near future. Take a look at our website, 6G-ready.org, to get more inspirations and details on what we are currently doing and what our roadmaps look in more detail. Thank you for your attention. And if you want to read a little bit more on what 6G might be, there's also a new book coming up on 6G technologies, which is edited by Wiley and IEEE. And this might be interesting for your students and for, let's say, yourself. Thanks for your attention. Bye-bye.
Thank you.
Thank you. Thank you so much, Professor Thomas Magedanz and Dr. Marius Corici. It was a great presentation about 6G. It was very fruitful and amount of information. So thank you so much.